And so we're going to be looking at 1.6. Now 1.6 is solving different types of equations. And so these are all a little bit different, and all of them are going to be solved in a little bit different ways. And there are several basic types that we're going to be looking at. We're going to be looking at equations that involve fractions in the denominator with an x. We're going to be looking at square root equations. And we're also going to be looking at some more complicated kind of substitution questions and questions that involve an x as a power, as an exponent. So we're going to first start off with looking at some rational equations. And rational equations, well, these are our fractions. So when we talk about rational equations, well, these are going to be our fractions. And when we talk about these rational equations, we first need to talk about the domain. And the domain is going to be the possible values of x. So the domain is going to be our possible values of x. And what we do not want is no division by 0. So we never want division by 0. That's something that we just cannot have. So we're going to look at some of these. We're not going to be solving these. We're just going to be determining which numbers will not work in this as possible answers. And then we're going to be writing up our domain. Okay, so we're going to be talking about what values of x can work, and then cannot work, and then we're also going to be writing up our domains. So we're not going to be solving these, and these are going to go right along with questions 18 through 20 in your homework. Now, some of these may require us to factor. Some of these, you might be able to just look at them and see what values won't work. So we're going to find the domain of this fraction here. Okay, now, when we talk about the domain, we need to find out what numbers are not in the domain. And what we cannot have is we cannot have division by 0. So what we do is we set the denominator to 0. And these are actually very easy. So we set our denominator to 0. And so that gives me then x minus 9 equals 0. And we're going to add that 9 over. And x equals 9, that is the number that is not in the domain. And why would 9 not be in the domain? Well, if I put 9 back into my original expression here, 9 minus 9 gives you 0 in the denominator, right? And any number, remember from intermediate algebra and elementary algebra, any number that is divided by 0 is not 0, it is undefined. Okay, so that is not in the domain. Now, how do we write up our domain? We write up our domain like this. Our domain is going to be negative infinity to 9 union 9 to positive infinity. And what that is saying is this is interval notation, and this is simply saying that every number works except for the number 9. Because the number 9 would give you division by 0. So let's do a couple more of these, and then we'll actually learn how to solve these rational equations. And there's actually a step-by-step procedure. All of these questions have a step-by-step procedure. So let's again find the domain. About 9x over 4x minus 3 plus 7 over 8x minus 2. How about plus 9 over x squared plus 6x plus 5. Now, there can be several numbers that are not in the domain. And what we do is we look at each denominator. Now, we do not care at all about the numerators when we talk about the domain. The only parts that we're going to be looking at is we're going to be looking at these denominators. So that's the only parts we're going to be looking at. And there can be several numbers that are not in the domain. Last one just had one, but this one is going to have several. So let's go ahead and see if we can't find them. And we're going to have several equations to work with. So we've got 4x minus 3 equals 0. That's our first one. We're going to add that 3. So 4x equals 3. Divide by our 4. And one number that is not in the domain is 3/4. Okay? Because 3/4 would give you division by 0 here. We don't want that. We need to find it so we can take it out. What about the next one? 8x minus 2 equals 0. So 8x equals 2. Divide by the 8, and we're going to reduce that down. And that reduces down to 1/4. And then our last one, we're going to have to factor. So this one's going to require us to factor. And most of these are going to be very simple to factor. They're not going to be hugely complicated. They're actually going to be pretty easy to factor. And so when I factor this, first times the last is a 5. And what two numbers multiply together to give me 5, add together to give me 6 in the middle? Does anybody know what those two numbers would be? Yep, very good work. 5 and 1, right? Okay. That then factors into x plus 5, x plus 1. And then we've got x plus 5 equals 0. So x equals a negative 5. And then we've got x plus 1 equals 0. So x equals a negative 1. Now let's go ahead and answer the question. Again, we're not solving these for 18 through 20. We're just finding the numbers not in the domain and the domain itself. So what numbers are not in the domain? And we've got actually 4 of them here. So the numbers that are not in the domain are going to be 3/4, 1/4, negative 5, and negative 1. Those are the numbers that are not in the domain. And how would we write the domain if we so chose to? If I were to write the domain, it would be negative infinity. And our smallest number is negative 5. Then we would go negative 5 to the next number, which would be negative 1. And then we would go negative 1 to positive 1/4. And then finally, we would go positive 1/4 to 3/4. And then finally, one more, 3/4 to infinity. And you don't have to write out the domains for these. All I'm really looking for is the numbers that are not in the domain. But this is what your domain would look like. And these unions just mean every number works except for the number in the splits. So 5 wouldn't work, negative 1 won't work, 1/4 won't work, and 3/4 won't work. But every other number is a candidate to be a solution. And now let's talk about how we're going to be solving these rational equations. And they're really not difficult to solve. These are going to be much simpler than what we did on Wednesday was solving those equations from 1.5. These, I think, are a lot easier. So now we're going to look at how to solve rational solutions. Rational equations. So we're going to solve rational equations. And there's a step-by-step procedure. Step number 1 is what you need to do is you need to find the numbers not in the domain. So that's what we just did. So these just really kind of build on themselves. Then what we do is we clear the fractions. And after we have cleared the fractions, okay, so we clear our fractions, and then we solve that resulting equation. And then we have to check our answers. With step number 1. Okay, so that's what we're going to be doing. We're going to be find the numbers that are not in the domain. We're going to be clearing fractions. We're going to solve it. And then we're going to check and see which answers work by looking back at step number 1. Some of these are much, much easier to solve than others. And so we're going to look at an easy one to solve, and then we're going to look at a more difficult one to solve. So we're going to start with an easier one. And this, I think, is one of the more difficult, easier ones, but we're still going to look at this. And this is question 24. And this is on page 164. All right, so we're going to look at question 24 on page 164. And this just requires a lot of factoring. Okay, so this is what we're going to try to solve. And it looks a lot more complicated than it actually is, because we're going to work with this one, and this is not going to be difficult. It looks complicated, but it is really not. Now, we need to factor each and every one of these denominators. So each one of them, we're going to have to factor so that we can find our domains. Because that's going to be our goal first, is to find our domains. So we're going to begin by factoring. And let's start with our first one. And these should factor easily. These are not going to be difficult to factor. We want to factor x squared plus x minus 2. So first times the last is a minus 2. And if we remember our signs, that minus 2, well, that's negative, so that means one of them's going to be what? Positive, right? One of them's going to be negative, and the sign in the middle is positive. So which one's going to be positive and which one's going to be negative? The 2 or the 1? 2 should be what? 2 should be the positive, and 1 should be the negative, because those go together and give you a positive 1, and they multiply together to give you a negative 2. So that one's been factored, and that is x plus 2, x minus 1. Next one, x squared minus 1. Now, we should remember kind of from intermediate algebra, when we talked about this, that this is a difference of squares. We're not solving it. We're not saying to 0. We need to factor it. So when we look at this as a difference of squares, 1's a perfect square, right? And x squared is a perfect square. So we can split this up into x plus 1 and x minus 1, right? Because it's a difference of squares. If this would have been a 4, then it would be x plus 2, x minus 1. Or sorry, x minus 2, because if this was a 4, that would be a perfect square of 2. But this is a 1. 1 is a perfect square of 1. So we factor that one. And then we can't get rid of the 2. We have to actually factor it out. So the last one that we want to factor is we've got 2x squared plus 6x plus 4. And so when I look at all these have a what number in common at the very beginning? 2. So we're not solving it. We're factoring, so we're not going to divide it out. We're just going to have to put the 2 in front. And that's going to then leave you with an x squared. 6 divided by 2 is a 3x. 4 divided by 2 is a 2. Okay. And now we should be able to factor this. First times the last is a 2. And what two numbers are going to multiply together to give me 2? Add together to give me 3. Yep, 2 and 1. Okay. And both positive in this case. So that's going to now factor into x plus 2, x plus 1. And we are about halfway done. And there are easier ones. All right, I picked this one because this is one of the more kind of mid-level problem. Now we rewrite. And so the first one is 3 over x plus 2, x minus 1. The next one, will we factor that x squared minus 1. There should be a minus here. So we factored that into x plus 1, x minus 1. Bring down our equals, and then we've got a 7 over, we've got a 2 out in front, x plus 2, x plus 1. So everything has been factored, right? Now we need to find the numbers that do not work. And you can almost just look at it and see what numbers do not work. These have been factored, so we can just look at it basically and see what numbers do not work. So if I look at my first one, what numbers don't work? Okay, what would give me 0 here? If I look at x plus 2 equals 0, so that tells me then that x equals a what? Negative 2. If I plug a negative 2 in here, right? Minus 2 plus 2, what does that give you here? 0. Okay? We can't have that. So one number that doesn't work is going to be a negative 2. What's another number that doesn't work? Well, x minus 1 equals 0. So what number's not going to work? Positive 1 doesn't work. Now we only write them once. So we have the x minus 1. We solve that. That gave us the once. We don't have to work with it here, right? Because we already did it here. So another one is going to be x plus 1 equals 0. So then what other number won't work? Minus 1. And then finally, this 2 out in front, this doesn't really matter. All right, so that's not going to matter. All we care about is our parentheses here and here. So what do we have for our parentheses? Well, we've got x plus 2 equals 0. So another one that doesn't work is a minus 2. Now, that's already taken care of here. Right? And the other one doesn't work either because x plus 1 equals 0. Well, that's a minus 1, and that's already taken care of right here. So what numbers do not work? So the numbers that do not work, first off, are going to be these. So that's what we had to do at the very beginning. And it's almost done. It's really downhill from here. That was actually the hard part. And I should have left myself some more room, but that's okay, because we're going to clear the fractions next. So that was step 1. Now we're moving on to step number 2. And when we look at this, we need to think about everything that we need to get rid of all the denominators. And again, I should have left myself some more room, but that's okay, because we're going to have to multiply everything by something to get rid of things. let's first look at this in terms of the numbers. So we look at only our denominators. So when I look at the denominators down here, what's our first and only number that we have? We have a 2. So we want to get rid of our fractions, right? So we need a 2. So we're going to have to multiply everything by a 2. And then what else do we need? Well, we need an x plus 2. We need an x minus 1. And we also need an x plus 1. Because that's going to get rid of everything. The 2 will cancel with that there. We always do the numbers first. So 2 will cancel with that. X plus 2 takes care of that one. That one. X minus 1 takes care of that and that. And then x plus 1 takes care of those. So that's going to get rid of everything. Now we simply distribute through. And I should have left myself some more room instead of cramming it in here. But that's still okay. Now let's see what's going to happen when we distribute. And we do each one individually. So first off, when I look at my first piece, is there a number down below? Is there a 2 down below? No. Okay? So we take the number 2. There's nothing to cancel. So 2 times 3 makes it a, we're multiplying here, 2 times 3 makes it a 6. And what can go away? The x plus 2 and the x plus 2 cancel. The x minus 1 and the x minus 1's cancel. But is there an x plus 1 down here on this piece? No. So what's left over with it? X plus 1, right? Now for the next one. We've got a minus. And 2. Is there a 2 down below to cancel? Nope. So 2 times negative 1 is a negative 2. The x plus 1 cancels. The x minus 1 cancels. But do we have an x plus 2 down here at all? No. So we will have a minus 2 from here. And then we'll have an x plus 2. And then we've got our equals. Now, on the right-hand side, it's a little bit different because the 2 and the 2, one's on the top, one's on the bottom, they cancel. We've got an x plus 2, cancels. X plus 1 cancels. And what's left over? 7 on the top. And an x minus 1. Now we're done. Now all we have to do is solve this. Right, so let's go ahead and solve this. So we're almost finished. We're going to solve it. And we're going to begin by distributing that 6 through. We're going to distribute the negative 2 through. And we're going to distribute that 7 through. So that's 6x plus 6. We've got a minus 2x, a minus 4 when we distribute. And that equals a 7x and a minus 7. Combining like terms on the left-hand side, we've got a 6x and a minus 2x that makes it a 4x. And we've got 6 minus 4 that leaves you with a positive 2. Move things around, so move that 7x over. And move that 2 over as well. So 4x minus 7x, so 4 minus 7. That's a minus 3x, so that's the left-hand side. Those can cancel. A minus 7 minus 2 makes it a minus 9. Divide both sides by a negative 3. And reduce it down. And so we've got x equals a positive 3. Now, what numbers will not work? What numbers cannot we have? What numbers can't we have? We cannot have minus 2, 1, or negative 1. So we got our answer to be 3. Is 3 one of those numbers that I said will not work? No. So that means 3 is our solution. And it was just a lot of factoring. It's not very difficult. It's just factoring, solving. Okay, we'll do one more, and then we'll take a short break. And this one will have some solutions, but this one, we're not really going to have any solution that works. And that can happen. And this one's actually easier to factor. I think. Okay, so we're going to be on step 1. And when we look at step 1, there's only one thing that we need to factor first, and that's this. And we just did this a moment ago. So let's factor x squared minus 1. And that's a difference of squares, right? And that's x plus 1, x minus 1. Now, we have done enough of these that we can probably look at this and we should be able to tell which numbers are not in the domain, which numbers are not possible solutions. So these numbers are not in the domain. Can anyone tell me what they might be? Let's look here. Yep, okay, 1 will take care of that one, and negative 1. So what numbers are not in the domain? Negative 1 and 1, right? Because if I plug a negative 1 in here, division by 0. If I plug a 1 in here, division by 0. These two are taken care of. Now we're going to clear the fractions, which this one's actually a little bit easier, truthfully, to clear the fractions on. This one we're going to have to factor, and this one's going to actually give us no solution. So let's look at this as a whole. Do we have any numbers down below our equal bar, or not division bars, not equal bars? Do we have any numbers below the division bars here? No. Okay, there's no number been factored out in front. So what we're going to have to use is, let's start with our first one, x plus 1. So we need an x plus 1, because that'll take care of that. And we also need an x minus 1. Is that all that we need? Yes, because x plus 1 cancels with that, x minus 1 cancels with that, and then they both cancel with that. Now we're going to distribute. The x plus 1s, well, those cancel. So the x plus 1s, they directly cancel down below. Those cancel. And what are we left with? Well, we're left with a negative x on top. And we've got an x minus 1. So there's that piece. Then what else do we have? On the next one, the x minus 1s, they cancel, don't they? So they're gone. And what do we have? We have a minus 1 times x plus 1. And then on the right-hand side, what do we have on the right-hand side here? Okay, negative 2, and those cancel, so that's it, isn't it? Right? Now we can solve. Now we will have to distribute, and we'll have to factor this, but that's okay. We can do that. So some are more difficult than others, and they're all different. So let's begin by distributing that negative through, and the negative 1 through as well. So that makes it a minus x squared. Negative and negative makes it a positive 1. And then a minus x and a minus 1. And that equals a negative 2. Those got distributed through. Let's combine like terms. So we have a minus x squared. 1 and minus 1, those cancel. Okay, let's make sure we didn't make a mistake here. Oh, that should be an x, shouldn't it? Okay, yep. About made a mistake, because when I distribute this negative x squared, I wrote it down wrong. Negative x times x is a negative x squared. Negative x times a negative 1 should be a positive x there. Sorry about that. That was my mistake, right? It should be a positive x, because negative and negative makes it positive, and the x times 1 makes it the x there. So the x's, they're going to cancel, and that's going to leave me with a minus x squared minus 1 equals that minus 2. And there's only one x, and that one x is squared, so that means we're going to use the square root property. And how do I know that? The only thing I have there is an x squared. So I move that 1 over with addition. And that gives you a minus x squared equals a minus 1. Now, when we take these square roots, we need to think about it like we're solving for x. So if I gave you this, and this was minus x equals a minus 1, we would want to solve for x, we would divide by a minus 1, right? We're going to do the same process here. That way we get our x squared by itself. A negative 1 divided by negative 1 is 1. And how do we get rid of a square? Square root again. Whenever we take a square root, we leave the plus or minus. And 1 is unique because 1 has a square root of what? Square root of 1 is 1. It's itself. So we actually have x equals 1 and x equals minus 1 for our possible answers. And I say these are possible because now we need to go back and check them. And what numbers can we not have? Let's go back up and look. What numbers are not allowed in the domain? 1 and negative 1. So what's going to happen with these? 1 doesn't work, does it? Because it's up here. And so 1 doesn't work. Negative 1 is also not in the domain. So neither one of them work. So therefore we have what? No solution. That's it. Okay. 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 So you're going to try to take it today during class time? Is that what you're going to do? Okay, well, I'll go ahead and I'll be right back.
I still need to get my notebooks.
Yep, I'll put you in a quiet room. We'll get you started now so you can get that exam done.